In this tutorial, I want to quickly demonstrate what we mean when we talk about the direction of a DNA strand. So here we've got a nucleotide, which means there is a nitrogenous base attached to a sugar, and this sugar can be either ribose or deoxyribose, and we've got a phosphate residue. Now let's look at the residues in this sugar and how they are actually labeled. So this carbon here in this position here, and I need to label this, in this position here would be the 1' carbon. So here is the 1' carbon. Here we've got the 2' carbon, and it can be either a hydroxy group, then it would be RNA, or it could be a hydrogen, then it would be DNA. This position here, this carbon here, is in the 3' position. Here we've got the 4' position, and this carbon here that actually carries the phosphate group is the 5' carbon. So these are the carbons, and in a way, how I see it is a little bit like, well, it's like an elephant. We can imagine that the trunk is the 5' end of the sugar. So we would have here the 5' end of the sugar. That's the 5' position. Here we've got the 3' position with an OH group. And here we might have the base in the 1' position attached to it. So that is our elephant here. And as I said, here we've got the 5', and here we would have the phosphate group attached to the 5' position. So what can this elephant do? Now when elephants travel as a family, they like to hold the tail of the preceding elephant with their trunk. So here we have the 5' end of the elephant with a phosphate group. Here we've got a base, like a shoe, and here we've got the 3' end. And this is attached to the next elephant, here again with the 5' end. Here we might have yet another base, and here we've got the 3' end of the elephant. And in between the 3' and the 5', here we would have the phosphate group that sits in between, that comes actually from this 5' end. And the next elephant again grabs the previous elephant with the trunk. Here we've got the 5' end, the phosphate group. Here we might have yet another base located, and we've got the 3' end of the elephant, or rather the sugar in the DNA. So that gives it a very clear direction from 5', where the trunk of the first elephant is, to the 3' end, where the bum of the last elephant is. And if there's then another elephant coming in, they would join the party right here at the next elephant, at the last elephant. So here with their trunk, and you can tell my artistic expression of elephants is not great, but you get the gist. So it would join again at the 5' with the 5' trunk, and it would have a tail here at the 3', and the next elephant then could join the party again at this side. They can't join at the front because at the front there is the boss, of course. So this is in a way how I depict the direction of DNA, and it's very clear. It is from 5' where the boss is, 5' to 3'. And that is exactly how I actually imagine DNA to be organized, from 5' to 3' with the bases sticking out. And that is basically what we have here with the nucleotide. And hopefully this makes sense, and thank you for watching.